Why don't ants get sick? Because of their little antibodies. Actually, ants don't have antibodies. I mean, they do have antibodies, but they don't have the proteins that fight infection like vertebrates like you and me have. Insects are much less advanced and rely on a much smaller toolkit when they fight an infection, including PRRs, or pattern recognition receptors. PRRs are proteins that look for certain molecular patterns that are characteristic of pathogens, but not host cells. When PRRs find these pathogen-associated molecular patterns, or PAMPs, they tell the rest of the cell about it and activate an immune response. One of the PRRs in mosquitoes is called AGD-SCAM and can potentially be used to combat malaria transmission. Malaria is one of the leading infectious causes of death worldwide and caused 608,000 fatalities in 2022. It's caused by the protozoan Plasmodium, which is actually a parasite that lives in the mosquito. Obviously, the mosquito doesn't like the parasite, so their immune system tries to attack it, but it doesn't always do a good enough job. So we want to enhance the immune response by making a better version of AGD-SCAM. Okay, so PRRs are proteins, so to change the type of AGD-SCAM we're making, we have to change how the proteins are made. To understand how we'll do this, think of it this way. If proteins are a cake, then DNA is the recipe book and RNA is the chef. Okay, so let's say you have a strand of pre-mRNA, which is a type of RNA. Before it's used to make protein, it goes through some processing where it gets some accessories, it gets chopped up in different ways. Pre-mRNA has segments called exons, which code for proteins, and introns, which are removed. Splicing factors choose which exons make the final cut, and different combinations will result in different forms of AGD-SCAM that can be better or worse at fighting Plasmodium. So to make the perfect mosquito that kills Plasmodium before it gets to us, we have to change the splicing factors to make the best version of AGD-SCAM. So researchers figured out which versions of AGD-SCAM are the best at fighting Plasmodium, and then analyzed how two splicing factors, caper and RSF1, affected the production of those prime AGD-SCAM forms. When caper was silenced, fewer of those good splice forms were produced, but when RSF1 was silenced, more of those good splice forms were produced. So better mosquitoes will have increased caper activity and reduced RSF1 activity. Researchers used this knowledge to genetically engineer mosquitoes with increased resistance to the malaria parasite. Since Plasmodium is less successful in these genetically modified mosquitoes, they are less likely to spread malaria, so less people will get sick. Isn't that cool? We can use science to engineer mosquitoes to save lives. Genetic engineering is a tool with limitless applications and can be used to stop the spread of disease, but also to grow more food, cure diseases like vitamin A deficiency, combat climate change, and so much more. If you want to read more about AGD-SCAM and efforts to combat malaria transmission using biotechnology, you can check out this paper I wrote, which includes toxic fungi, gene drives, and symbiotic bacteria. Link is in the doobly-doo. Link is in the doobly-doo. Guys, check it out, please. It's in the doobly-doo.